My name is Dave McJannet from HashiCorp. We talk to organizations of all sizes about their infrastructure plans, and specifically how they're adopting this cloud operating model for infrastructure as they navigate this transition to building new applications to differentiate their business. So I'm going to spend maybe a couple of minutes here just describing how our products are used to address some of the core challenges around ops, security, and networking in particular, and hopefully to leave you with an idea for how to address the challenge. So I think we can all agree we're going through this generational shift in the way that people run infrastructure. We often find it useful just to simplify at the highest level what's happening. And I would draw it kind of like this, is we're going from a world where we have a dedicated data center, where we all have servers that we run, to this new world, which is really the notion of cloud, where it started off as, okay, let me create a pool of infrastructure on premises, then let me add Amazon to that, then that became, Azure, and now we have this sort of multi-cloud reality that we all appreciate to be real. Now the catalyst for that is actually pretty simple. Why are we all moving to cloud infrastructure? Well, it's actually about building net new systems of engagement. Jeffrey Moore uses the term of systems of record and systems of engagement. Systems of records are those core systems you have in any company. Systems of engagement are the net new applications you're building that leverage the data in your core systems. And by and large, your systems of record, let's do systems of record, are going to be on premises. So the catalyst for the shift in infrastructure is largely around the creation of net new systems of engagement that are going to be on cloud. It therefore is inevitable that you're going to be multi-cloud because you're going to have some of your infrastructure on premises, and also you're going to have some on Amazon, some on Azure. But even if you're just going to run on Amazon, you're also going to have some data on-prem. The implications of that really are twofold. Number one is on the tooling you're going to use to basically run that infrastructure, which has to contemplate an entirely new reality. And the second one is on the process. You're going from a very traditional world of tooling based on this static data center, which we would generally refer to as being static infrastructure, and you're going to this new world of dynamic infrastructure where the properties are very different. But as it relates to the people side of the process, you're going from a very ticket-based model, hey, I need infrastructure, open a ticket, you stand it up, to a self-service model. So from ticket-based to self-service. And those two things, both the changing nature of the infrastructure itself, plus the changing requirement for self-service so I can build net new systems of engagement quickly, is causing an entire replatforming of how people run infrastructure. I would then decompose it. I'll say that's sort of concept number one. I'll decompose that then into the layers of infrastructure. There's sort of the core infrastructure. Think of that as how do I provision compute capacity. Basically, I'm going from a world where I have dedicated infrastructure, that's my server, that's your server, to this world here in the dynamic world, which is on demand. Right? I provision compute capacity when I need it. At the security layer, pretty significantly a different world. I had the ability to say everything within this IP range here I can trust, so basically it's high trust. And I use IP as the basis of who can talk to whom. Right? If I have an application here, I can talk to a database in here, as long as it's in that data center, I will let that happen. To a world of actually low trust, because I no longer control the network here. And therefore, the big shift is to the use of identity as the basis of security. So let me authenticate your identity before I give you access to something. I think this concept's relatively well understood in the cloud world. And as a result, I think we're all seeing the idea of identity in security as being a pretty common thesis. At the networking layer, I go from what we would refer to as host-based networking, which is, hey, this machine has a physical location, therefore I can assign an IP address to it because it has a physical host, to the world of service-based networking, which is hey, I may have an application artifact here, I may have a database over here. They're going to move around. Let me not try and pretend that I can control the IP address of them and move to the world of, instead of IP-based, host-based networking to service-based networking in this new world. So conceptually, very, very different world. And then I'll do it in different color just because developers are ultimately what we're all doing this for. You're going from my developers drop the applications onto dedicated infrastructure here to dropping it onto a fleet of infrastructure here. So these 4 changes are pretty profound as it relates to how people, operate infrastructure. And it's causing the market at large to sort of just reshift the way that they think about infrastructure entirely. Our whole thesis is predicated on this shift, which is to say, hey, let me decompose the problem in a way that I've done here, is to say, hey, in this new world of this dynamic infrastructure model, there are ops people, there are security people, there are networking people, and then of course, there are developers, and they are the ones that are building these net new systems of engagement. All 4 of these participants have to figure out how to run infrastructure in this new model. So let me just break it down into those roles. The ops people are having to figure out how to enable people to provision infrastructure on demand across a wide variety of infrastructure types, and Terraform is our product there. Terraform is ubiquitous in that it is used as a common provisioning mechanism across any infrastructure type, whether that's on-premises, whether that's Amazon, whether that's Azure. I don't know what percentage of the infrastructure provisioned by Terraform users on the clouds happens every day, but it's a significant percentage. Very, very simply, the way Terraform works is like this. It has the idea of Terraform core, just a command line tool, and then there's a provider for every environment you want to interface with. So on Amazon, there might be 500 different services that you can configure. On Azure, there may be 300 services you configure. On Google, there may be 200 because it's maybe less mature. On vSphere, well, there may be 200. You get the point. What Terraform allows you to do is have a common operational experience to configure all the unique services on top of any of these cloud platforms. There are in fact 2 categories of providers. We call these providers. There are the core infrastructure providers, and then there's a provider for really every other ISV you may want to configure, whether that's, I want to configure F5 as part of the provisioning experience. I want to provision Kubernetes. I want to provision Palo Alto Networks. I'll draw that slightly more elegantly, Palo Alto Networks. There are, no less than 200 plus third-party providers that you can use. So what I can now do is in a single template, a single Terraform template, I can codify the provisioning of maybe the 4 Amazon services plus the 6 dependent services, or maybe four dependent services in a single Terraform template. What this allows the ops people to do is to say, here is your approved template of not just the Amazon components that I'm going to allow you to provision, but also the configuration of all the dependencies on top of it. This is how people, by and large, are addressing the challenge of how do I enable this provisioning on demand model across multiple infrastructure types. Again, here, we're not creating a lowest common denominator of services, but rather we're just creating a common workflow across all these different infrastructure types. At the security layer, we have a product called Vault. Vault allows you to leverage any source of identity to enforce access to systems or applications. Very, very simply, I've talked about the idea of, in the traditional world, I have a client, maybe it's an application, needs to make a request of a back-end system, maybe it's a database, and historically, if you give me the credentials, I give you the information. In the high-trust world that we're accustomed to, that's a valid assumption and a valid model. In the low-trust model of cloud, that's probably not the recommended way. You want to be able to authenticate the identity against some trusted source of identity that you have before giving access to that application or that back-end system. So Vault inserts itself in the middle and says, let me authenticate against whichever identity model you care about. And you're going to have multiple, because it turns out all of the cloud providers use identity as the basis for how they do security. So Amazon has something called the Amazon IAM model. Azure has something called the Azure Active Directory. Google has the IAM model. You might use Active Directory or LDAP on premises. So you may have an application running on Amazon that needs to connect to a database that's running on premises. You're now having to use identity as the basis for that connectivity, but they have different identity models. So Vault lets you authenticate against any identity model that you may care about. Active Directory, the IAM models of the clouds, maybe it's Okta if that's what you use for some of your pieces, maybe it's OAuth from GitHub. It doesn't matter. Vault lets you authenticate against any of them. So you can basically change the routing that the client makes the request of Vault to authenticate against the identity model of the backend system. Once that's approved, a credential is created for you, and what's given back is actually just a token to the end user. So in this way, you have a way to centralize secrets management across any application type, and the policy of that is set by the security team. So what Vault now allows you to do is sort of use this notion of identity to enforce application to any system or application in your fleet, regardless of the identity model being used. So the idea of creating a central secrets management platform is extraordinarily compelling in this new world. There's a secondarily derivative use case once people are using Vault. First one is around centralizing secrets. The next one ends up being around encryption. So now, because every application is coming to Vault to get its token, to authenticate before it's given access to a backend system, I can now enforce a policy that says now encrypt everything in that flow. So there's no change to the application really. It's really just a setting that the security team is applying to now enable encryption of anything in the cloud fleet. If you can centralize secrets and credentials management, and you can encrypt all data in rest and in flight in this cloud world, you've gone 99% of the way to addressing the security challenge. The third element of our portfolio is something called Consul, and Consul is actually, believe it or not, our most widely used product. It's the most widely deployed product. What Consul allows you to do is address the challenge of service-based networking. So in the traditional world, I would have created, when I drop my application artifact into my environment, I would have said, hey, that's a database, this is an app server, and it basically saying, assign an IP address to it. What Consul does, rather than requiring you to do that, because in order to establish a static IP address, I need to put a load balancer in front of every one of these things that I deploy. You end up with hundreds, if not thousands, of load balancers to create that mechanism. Then I say 1.1.1.1, and that's 1.1.1.2. What Consul allows you to do is basically the notion of Consul server runs. Then when an application or an artifact of an element gets deployed, it has a little client library with it that gets discovered, and now Consul knows where everything is. So what Consul is doing is creating a common service registry that says this is where everything is, and it's doing it not by IP address, but by name. So that's app server 1, that's database 1. So what Consul's now done is created a common service registry as to where everything is. Now I can interrogate Consul to be able to route traffic. So rather than having to have people install expensive load balancers, which are expensive financially, but also more expensive in terms of application traffic requirements, I can actually just route traffic directly between the services rather than going north-south for every application request. It doesn't eliminate the need for load balancers completely, but it certainly reduces the number of load balancers that are required. So Consul is, number one, a common service registry, but then the derivative use cases of that are, now I can use that for routing. Number two, I can now use that for service segmentation. And this is where people start to talk about the idea of a service mesh. Right? The service mesh really just says, hey, let me declare who can talk to whom, and when they talk, enforce encryption between the services when they speak. So very conceptually similar to the way that Vault sort of thinks about changing security, which doesn't try and mimic what was done in the old world, but it says, hey, what are my key problems, and let me try and solve those. Console in the networking world says, let me think about what are the key problems I have, which is where is everything? And then number two, let me start routing traffic based on the location of everything, and let me now enforce mutual TLS across all the services that I might have. So these end up being the three core elements that enable all the different kinds of applications you have in your environment. You're gonna have some Java apps, some C# apps, some Cloud Foundry apps, some Kubernetes apps, some container-based applications. And the problem here is actually one of scheduling. And our fourth product is called Nomad. Nomad is an application scheduler that says whether it's a C# application or a VM, or whether it is a Java application or a Cloud Foundry-based application, let me just schedule those applications across that fleet so that if you're going to spin up all this infrastructure, at least the binary packing is being done in a way that you're best scheduling the work across the fleet that you're now paying for. So these are essentially the core concepts. Number one is sort of the shift from static to dynamic infrastructure and a double click on the sort of what that means at each layer. Number two, this is how our portfolio works. These are individual products that can meet the needs of each of these four elements I've described. Now, the third thing, I think the most common thing, is to say, well, how do I actually solve this challenge of self-service as I'm going cloud? And what most of our customers do, they sort of draw the picture and say, hey, I have this application element or this application artifact, and I need to figure out how to get it to here. That's cloud number one, that's cloud number two, that's maybe cloud number three. What they have to do is they say, hey, well, rather than just deploying the application artifact itself, I actually need to satisfy the needs of the ops, security, and networking teams so that when that application gets to the cloud environment that it is, again, A, it is safe, B, it's going to see traffic, and three, it's not super expensive. So I have to solve the needs of the ops, security, and networking people. To do that, most of our customers end up creating a central shared service of Terraform Enterprise, Vault Enterprise, and Console Enterprise. Right? What Terraform allows them to do is to say, hey, let me create these set of templates that as long as someone uses, they have essentially got my implicit authorization for that application to go to cloud. Now you can provision it 100 times a day if you want to, because I know that it's got all the application elements that I, as an ops person, require. Number two, if every artifact comes to Vault to get its credentials, then the security team is going to say, great, now I'm not worried about you hard-coding credentials in your applications, and you've also given me a control point for all encryption that I might want to do in the future. Then I'm going to let you go. Number three, if you include console client, when the artifact gets deployed, then console server will discover it, and I can start routing traffic immediately. So those three elements become the consistent pieces, whether it's a Java app, whether it's a C# app, or a Cloud Foundry app, or whatever it might be. Now, to solve the needs of security and policy, the commercial versions add essentially a common way to do policy that says, hey, for example, in Terraform, nobody can provision after 5 p.m. on a Friday. If it's not 5 p.m. on a Friday, then yes, let it go. If it is, don't let it go. It also requires the idea of governance. Right? These are highly regulated companies for the most part. Therefore, they need audit trails. Who did what? How did it go? Who's allowed access to be able to create things like ACLs? If you overlay central set of shared services with our commercial versions that also address the needs of policy and governance, you've now created this sort of industrial process of how do I deliver new applications quickly on the cloud infrastructure that both acknowledge how different the realities of this cloud world are, and number two, create the ability for self-service. By creating the central shared service within their organizations, this is how Global 2000 entities can deliver applications the same way that the smaller startup community does. So I hope this gives you a sense for how we think about the evolution in the world of infrastructure, and specifically how the HashiCorp products enable this cloud operating model that frankly underpins many of the applications we use all day, every day. We have a white paper that you can take a look at called the Cloud Operating Model on our website. I encourage you to download that. Or if we can help more directly, we're certainly available and eager to whenever you're ready. Thank you.